Today I'm going to be speaking about understanding the real-time ecosystem. So before I go forward, how many of you know about the real-time technology or how real-time applications work? Okay, not so many, so good. It's going to be a beginner's talk, and let's go forward. So as Sunny mentioned, I'm Srushtika Neelakantam, and I've been a long-time contributor and volunteer at Mozilla, where I've been involved in a lot of different programs, like the Mozilla Reps program, the Campus Advisory Committee, as well as the Mozilla Tech Speakers program, which is very interesting, where you get trained in public tech speaking for about 6 weeks, and then if you're interested in speaking about technologies that make web a better place, Mozilla supports you in every way possible, which is cool, right? And last year, I co-authored a book along with a friend titled Learning Web-Based Virtual Reality, which was published by Apris. So if you have questions in with regard to any of those, come catch me later. And right now, I'm a developer advocate at a company called Ably Realtime, and that's what I'm going to be speaking about today. So what exactly is real-time technology? Now, a lot of people tend to think that real-time is something that happens instantly, right? So say we have a trigger that's making some cause, and we expect that in the real-time world, that that effect happens almost instantly. While this is well and good to think about that that's what it happens like, but in reality, real-time is all about getting some data within a particular period of time, and this time is different for different use cases, and it is supposed to be very minimum. In fact, it is as minimum as 100 milliseconds, which again, you would argue that it's almost instant, right? But of course, the technical argument of whether it is instant or if it is lagging by a little amount of time stays right there. So if we look at a couple of examples that work in real time, we have the most famous one, which is the Uber application, where you can order, you can book a cab, and you can see the icon of the cab move in real time as the driver is driving the car to come to you, and you can see that icon move in real time, isn't it? And you have the document collaboration tools, where your friend living in some other continent is typing in the same document as you are, and as he presses some key, you are actually seeing that letter, right? Which is at high speed and from a lot of distance away. Again, that is real time. And you also have the stock market's price changing at a very rapid speed, and you definitely have to know what the current time is like at this moment, because it changes every moment, isn't it? So in a sense, we can say live is real time, because everything, the real time applications make it possible for something to be said as live. So even if you see live streaming of a match on your TV, it is again real time, because something is happening in the real world, and that's almost the same instant at which you see that sitting in some other corner of the world. Now, from what we know about how the internet works or how the web works, how are these applications? How do these applications even work? How is it possible that you can actually receive the data sent by someone from some other part of the world at such high speed and such continuous updates? It all happens in a very smooth fashion, right? The Uber car, the icon of the Uber car that we see, it smoothly moves on the map on your phone, right? So how is it made possible? So let's figure that out next. But before I move forward, I'm going to oversimplify a lot of stuff which you probably already know. So bear with me on this, because it'll only preserve the context for what I'm going to discuss further. So let's begin with, ta-da, HTTP. Now, I know that all of you know HTTP. Every one of us, that's the basic thing that we learn when we start off with web programming or anything, basically tech in general, hypertext transfer protocol. As we all know, we have a client, a server. You just send the server a request, requesting for some data that the server has or the service that the server can provide. And depending on the availability of the data or ability to provide that service, it'll give back to you some response, right? That's it. But if you think about real-time applications, say consider the Uber application that I just showed. How would it look like if we were to do HTTP request? we would ask, simple, right? We would ask the server, hey, you know what? I'm interested in knowing where the car currently is, what the location of the car is. And the server would ask the GPS guy sitting in the phone, and it would take the location data and give it back to me. But is it enough? We ask once, and it returns the location data once, and that's it. Unless you ask it again, that's all the data you have. So how is it, again, made possible that the car is continuously moving? So HTTP is no use to us in the real-time scenario, right? Something that comes to our mind, looking at HTTP is, why not ask the server again and again for this data, which we do by AJAX polling. So in AJAX polling, it's exactly like the request and response, in HTTP, except that it is repeated again and again. So every time you want the location data, you would be like, hey, server, can you give me the location data of this car so that I can update the app at the client side? And the server will give you back the location data. And as soon as it gives back to you the location data, you'll ask the server again, hey, do you have any new location data now with which I need to update the map with? And it'll give you the new location data. But it's all so much overhead, right? With each and every request and response cycle, there's the connection setup phase, all the authentication phase that is involved, because each request is separate or independent from other requests, correct? Because it's all stateless. So this is so much overhead and all redundant, and we do not want to have any kind of redundancy that has the possibility to reduce the speed with which data flows in our application, right? Because real-time is all about moving data at high speed. So what do we do next is a better way of AJAX polling, which is AJAX long polling, in which it is again the request and response done repeatedly, but the only difference being, after you send the request to the server, you actually keep the connection open for a little longer compared to the general request and response paradigm. So how it works is, you ask the server, hey, do you have any new location data? And the server would be like, sure, I'll check the GPS, and it'll have the new location data, but it'll not give back to you the response immediately. So it'll wait for some time, the connection is still open, the server is still connected to the client, and maybe during that frame of time, it has access to some newly created data. So it would be like position X plus 2, position X plus 3, and it'll give back all these three positions back to the client. But is it something, again, helpful in our case? It's not, right? For the Uber application, you would not expect the car to jump 3 steps and then wait for the next request and response cycle to come back, isn't it? It doesn't make sense. So even AJAX long polling is something that's not going to help us. And we have a new protocol, again, called HTTP2, which allows us to batch requests and responses together. Now, what happens here is, you have, instead of setting up a new request and response cycle, from the beginning, doing all the authentication and connection setup phases, you now can send 3 requests together and group them and send it to the server, and the server will process all these 3 requests and group the responses, send it back to the client. But in our Uber case, how would it look like? Request 1, hey server, do you have any new location data? Request 2, hey server, do you have any new location data? Request 3, hey server, do you have any new location data? So it's basically the same request grouped together, sent to the server, and the server would be like, yeah, sure, the location now is X. It's still X, because it's processing all these 3 requests at the same time. Probably at max, it might have X, X, and X plus 2 as 3 responses. Then you group these 3 responses and send them all together back to the client. And how would you expect the client to update the icon of the car on the map? It would be like maybe the latest, the last location, that is X plus 2, and that's it. Again, it's the same thing that happens with the, setting up the new request and response cycle, right? So it isn't helping us either. But with all the protocols that we have seen so far, we are expecting the client to somehow magically know when the server has access to new data. That is, when the GPS has created, is giving the server some new data, and then we ask the server to give us that new data. Whereas we have no idea if actually there is some new location or not. What if the car was just there at a signal or just parked somewhere, and the client doesn't even want to know because there's no new data, it's just the old data, right? So now comes the question of paradigms. So what we've done, what we've seen so far is the pull paradigm, where the client pulls the data from the server, by sending a request. So it would be like, okay, server, I want this data, and please give it to me, and the server sends back the response. That is pull paradigm, right? But what we are more interested in is called the push paradigm, where the client tells the server once, saying, hey, you know what, I'm interested in the location data of the car, just let me know whenever it changes. And the server would send back, here you go, I have new location data. Now here you go again, the car has moved 200 meters, and this is your new location data. It continuously sends back the data to the client again and again without the client requesting for it newly, right? But from what we've seen, how does the push paradigm work? Of course, we come across the protocol called Websockets. Now, WebSockets initially start off as an initial HTTP, as a HTTP handshake. Let us make an analogy of, using languages for communication. So let us think that these protocols are actually languages in which the client and the server speak with each other, right? So let's say the client connects to the server, says, because all the servers understand HTTP language, it's a given, but not all servers understand the WebSockets language, meaning not all of the platforms support WebSockets, right? So we need to be careful of that. So initially, we speak in the HTTP language saying, hey, server, I want to connect with you, and would you be fine to, move over the conversation for us to speak in the WebSocket language further on? And if the server complies with the WebSockets protocol, that means it knows the language, and it would say, sure, I'm connected with you successfully, and yes, definitely we can speak further on in the WebSockets protocol. And then it opens up a full duplex persistent connection, which means that now the client and the server both can speak with each other simultaneously, and the connection is persistent, meaning the connection is kept open for as long as the application is running. So you don't have to create any new request, you're still connected to the server, so this gives the server a way in which it can send back the data to you. It still recognizes you as the person who showed interest in some particular kind of data, and hence, as that particular data is being created, it pushes back to you that data, which makes sense, right? In our Uber application, this is the perfect solution. We would tell the server, I'm interested in the location data, and because the server is still connected to the client, that is me, it would keep on sending me new updates as they occur. And when one of them decide to close the connection, they just call it quits, and that is when the WebSockets connection is finally closed. Now that we know about what goes behind the hood of real-time applications, let's actually go through a couple of features, main features that we talk about when you enter the real-time world. So the first one, I'm sure you've heard of it, it's called PubSub. Now PubSub is a shorthand for publish subscribe. It's a messaging pattern in which you have publishers who publish the data that they have. In our case, the GPS is providing the platform some data, so it is publishing the location data, right? The mobile enabled with GPS is the publisher. And subscribers are subscribed to some data. They show interest in some particular kind of data and are given that data by the platform or a server, whichever is playing the mediator between the publisher and the subscriber. It is given that data as the new data is being published. So PubSub actually happens in two different ways. It can be either topic-based or content-based. So all the platforms, that is the mediator that occurs and routes all the publishers and subscribers' data so that subscribers get only the data that they're interested in. And while they get that data from the publishers, it can be done in either topic-based or content-based way. In topic-based, you have publishers who preset some channel names. So in this case, we have channels A, B, and C, and they would publish data, different data in all three different channels. So they would say publish one kind of data in A, other kind of data in B, and other kind of data in C. And as a subscriber, you're only allowed to choose one of these channels, and whatever is published in this channel, you will be notified or you will be given that data by the server. So it'll be pushed to you, right? So consider, the weather updates. Say I have the three channels, say weather for Helsinki, weather for Germany, weather for England. So those three are the three channels that I'm publishing weather to, and I can be interested in only one of these three channels. But what if I was interested in knowing the weather of Helsinki only and not of complete Finland, because Finland is a complete channel, right? So that is when the content-based, publish-subscribe pattern helps us, because publishers basically publish all the data, whereas it's is the responsibility of the platform to route the correct, to filter the data and route it to the correct subscriber according to what the subscriber needs. So in this case, the publisher would publish all the weather data it has, and the platform would be responsible to give the subscriber, say, if I'm interested in Helsinki and not Finland, Germany, or England, just Helsinki, it'll filter the weather data in terms of countries, then in terms of cities, and give me only the updates for Helsinki. And whatever platforms we have out there are either content-based or topic-based, as you'll see further. Then the next main feature that we have is presence. Now you've all seen the green dots on your Facebook friend list or the LinkedIn that has newly launched this feature, unless they have put themselves as offline, of course. So presence is a feature that lets you know who else is online on a particular application or a particular channel at the same instance as you are. So that is how all these social media applications tell you who's online, who's using Facebook at that moment, and things like that. So it's really a useful application. Even with multiplayer gaming, if you want to know if some other player is playing or not, if he's at all logged into the application or not, this is the feature you would use. Now, looking at all these features, the Websockets protocol and PubSub, presence, it really feels like real-time must be very hard to implement, right? To make an application work in real time, say the chat application, it has to go through so many hassles, so many protocols that you have to learn, and you have to make it work at the end of the day. But is it really hard? Definitely, it would seem hard if you're trying to make everything from scratch, but in today's world, we never do anything from scratch, right? Even if we're making a normal application, we still end up using 10 odd frameworks for it, which work small bits and pieces in your application, right? So even for this, there are a lot of platforms that are available that serve as this platform, the middleman between the publisher and the subscriber, that would make the delivery of messages between the publisher and the subscriber very easy and very fast. So you would ideally use one of these platforms, and I'm gonna show you how to work, how to work with it using Ably, using an example. So I'm gonna show a demo. I want you all to pull out your phones and visit this website, this link, and do not do anything yet. You'll just see 3 buttons. It's tiny.cc/realtime-voting. Yeah, I'm going to go back just a second. It is tiny.cc/realtime-voting. Okay, it is tiny.cc/realtime-voting. Are we all on it? Cool. So I have another application. Oh, do not press it yet. So the question is this conference awesome? And people are already voting. And you see that it's happening in real time, right? As you press the button, you can see the screen change in real time. And I'm not even refreshing it every time I want to fetch new data, because the connection between the subscriber, which is me, like the application running on my laptop, is connected to the platform, which in turn is connected to the publisher. Now you will find that there are a lot of people voting who are not even, which is not even equal to the number of people here, because obviously you can refresh and vote again. I have not included that feature, it's just a demo. Right? It's not a real voting. But okay, seems like a lot of people like it. And you can also say no, lie, maybe to just bring the red color up for a bit. So yeah, so that's how it works, right? So let's actually go look at the code of how easy it is to build an application like this. And of course, the application is in Angular. So as I said, the application that I had here, this is the subscriber, right? It is subscribed to the votes that is being published by your phone. So you are the publishers. There's a platform in between, and this is the subscriber. And I get updates because I've told the platform that I'm interested in these votes. And as publishers, I've made sure your votes go in a particular channel, as we'll see now, right? Seems like more and more people are starting to not like the conference. because it's end of the day. Anyways, so going here, I have a component. So by the way, the chart that I've implemented is using chart.js. It's a very cool framework for implementing all kinds of charts. You might want to check it out. So I've imported the chart here. And over here, I'm connecting to Ably, which is a platform, on the real-time library. Now, do not steal this API key. So I'm going to hide it real quick. And so Ably, like many other platforms, even with Ably, you can connect with both real-time and REST libraries. Now, why do these have real-time as well as REST libraries, that is on HTTP requests? Because we thought that HTTP has no role to play in the real-time world, right? But think about a situation when you are publishing some data, maybe one update every 5 hours. Would it be best if you were connected via WebSockets and the connection was kept open for so long with one update sent every 5 minutes or every 5 hours, or one HTTP request done to the platforms telling, this is some data that I would like to give to you, and that's it? Obviously, HTTP one is more efficient, right? You don't want to open up a connection and eat up resources on both ends in these kinds of situations. So for applications like these, you definitely have a REST library with all these platforms, and hence with Ably as well. But here, since I want to know in real time about what you've voted, I'm using the real-time library. So I say ably.realtime, I give the API key, and then I attach to a channel. So if you observe, Ably is actually a topic-based PubSub, right? It's not a content-based PubSub. So I have different channels within which the publishers can subscribe data, and the subscriber can subscribe to one of these channels. So here I have a vote channel, and I'm getting that channel, which is basically creates the channel if it doesn't already exist. By the way, can you see the code? Everyone through the end? I'm going to increase the font a little bit. OK. So I get the channel. So this channel is created if it doesn't already exist, or it gets attached to it if there is such a channel within this application that exists. And I'm just doing simple math where if you voted yes, I'm just increasing the number of yes votes and no votes and maybe votes. And then I'm just implementing those as data within my chart. It's all very simple, and that's it. But the real-time code is only so much, right? What, 3 to 4 lines? And the whole application is just half a page, which is cool, right? This is on the subscriber's end. But even on the publisher's end, people are still voting. But on the publisher's side, I'm again attaching to the real-time library of Ably. Again, do not steal the API key. And I'm attaching to the same channel, which is vote-channel. So you're publishing to this channel, and I'm subscribed to this channel, and you say, whenever some button is clicked, I'm just publishing, right? I'm publishing an update, and I'm just giving different score for the different types of buttons that you've published. And again, in our subscriber, after it is attached, I just say subscribe to something called update. And whenever something updates, actually, it is calling a callback, which does the whole updating the chart thing, right? Which is really cool. And it is very convenient to do it using a platform like this. So that's how you would ideally do it, rather than trying to implement complete WebSockets architecture from scratch. Moving back to the presentation. Now, what do we already have with real-time applications? Now, real-time applications, when you think about them, you mostly think about, say, chats, notifications, and things like that, right? Well, of course, we have gaming. You have multiplayer, gamings online where someone from a different continent is playing a game with you online, and when he's moving the joystick, the character moves in the screen with no latency at all. Otherwise, you'll be killed in the game, basically, right? So you can't afford to have any latency. That's a real-time example. You also have gambling. You have events. So, you can have live events, which you see on TV. That is real-time as well. Then you have chat and social. Of course, the chat application, you send someone, some message, and the person doesn't. You see your WhatsApp or Messenger messages only when you refresh the page. No, right? You just push the data. And definitely, you have data, content, notifications, and alert, collaboration tools like Google Docs and things like that. But what else can we have in future in the real-time world? you can have embedded chat. Now with platforms like Ably, you don't really have to build a separate real-time application as a standalone application that has nothing but a real-time functionality. You can have your own application written in any framework and include a real-time functionality within it. So you can have like a website or a game and embed a chat in between the application somewhere, and it is possible to do that because all you have to do is attach to this platform through your app in whatever language this app is written, right? Which makes it very convenient for people to use that feature. And then omnichannel in-store. I think you've really seen this, but you haven't really seen this yet. But when you're shopping online, there are certain shops in the US that have already implemented this feature where you're shopping online and you like a product and would like to have a demo of it. And a person in the real store actually comes up and you can see the video, or you can ask him to do something instead of like calling. It's almost like video calling, but it happens in real time, right? So the person can actually walk you through the product, see if you like it or not. Say if you're looking for a guitar, you can have the person hold it to see the approximate size of the guitar, how it looks in real life than a picture, because video is always better than a picture. You can have it with omnichannel and in-store. And then crowdsourcing. Now, something like Google Maps, which tell you the traffic updates on the roads on the streets that you're currently driving in, you can actually crowdsource the data. So you can have hundreds of publishers crowdsource the data that these are publishing, collect at one place, and then make use of it in 1,000 different ways, for just like the Google app. So you can know if a lot of people are on the road and they're telling you that this is where I am, so most probably that particular street is congested, and it would show up as red in Google Maps, right? So you can use real time for that. And you can have smart automation in IoT. Well, for IoT, going back to the WebSockets discussion, is WebSockets the only protocol that we would use for any of the application that we build in the real-time ecosystem? The answer would be no, because WebSockets is the most popular one, but there are other protocols like MQTT, which are use case based. For instance, if you're trying to implement an IoT project where your sensors are publishing some data, setting up a WebSockets protocol can serve to be very complex for these sensors, which are actually running on battery and have limited power, right? So instead, you can set up something like MQTT protocol and easily get them publish the data, which again reroutes through the platform and is sent to the subscribers who are interested in it. Outdoor media is one of my favorites. I'm not sure if you've seen this, but a couple of days back on Facebook, there was a video which was released. It was an ad, a very big digital board on the street where people were walking. And it was an ad about domestic violence of women. And it actually was recognizing women, all the women who were walking across that ad. Like, it had a live video stream, and it was drawing boxes around only women and not men. So in order to grab their attention to the board so they can see the particular ad. So this is like a complete different new world of outdoor media that can be implemented if you add real-time functionality, right? It sounds really cool, and it solves the purpose of you looking at the ad and understanding what the ad is trying to sell you. And of course, in future, the interaction by humans is almost being reduced, and all the interaction will mostly be device to device or machine to machine. In such cases, real-time technologies are the ones which you would trust, because they just make the, as I've been telling all through this talk, they just make the whole transfer of messages or sharing of messages at very high speed possible. And then you have smart notifications. Now, these are not the same as your general regular notifications, where you just get notified when something happens in your app. Whereas, for instance, you have a news app or like an e-commerce app. Say you're looking at the website of it right now, but you also have the app in your phone. Would it be better if the notification was sent on your web app and put it as an alert because you're currently on that web page, opened up that on your screen? Or would it be better if you had a notification sent to your mobile, which you're not probably even using? So smart notifications are a way to send you notifications where and when you're most probably to look at them, which is the purpose of the app sending you the notifications, right? It wants you to look at the notification. So these are some very revolutionary ideas that can be made possible if you add real-time functionality in your applications. And according to Seagate's study last year, which was released last year, by 2025, 30% of all the data that exists would be real-time data. So with so much real-time data flowing around us, it's high time, I think, we get started with working on real-time applications and include the real-time functionality in our existing applications as well, depending on the use case, of course. And why Angular? Angular, I think, has a great potential to do wonderful things on the front end, but it needs some source, some way in which it can get the data that has to be populated in a very nice way with a great user experience, right? So if that data is coming via real time and the application supports real time, I think that's going to make things very better in the future. Thank you so much.